And
Okay, so this is what we will be doing today. We'll do our homework that had basically exponents and radicals, all right? And then we'll talk some more about radicals and exponents. And then I want to get into scientific notation. Now, before I start that, did everybody get their survey?
Yes.
Ms. Becker sent everybody a survey, a link to a survey. Did everyone get it?
I got it and I answer it, but I'm still getting it. I don't know if I should do it again.
Oh, you did it. You only should do it once. And it was just a few questions. So you did yours, Mercedes?
I answer all the questions and I give all my comments and but it came back again. So I'm saying,
I don't
why?
know. You submitted it? It said submitted?
Yes, and I touched submit.
Okay. Maureen, did you get it?
yeah,
Did you complete it?
not yet.
Please, it's really short. It's only what was, I'll say there's about 5 or 6 questions, right?
Yes. Can Miss
Yeah.
Becker tell if she got it?
She said she got it, but she didn't complete it.
No, Miss Becker, if she saw mine.
I don't know if she would see it.
Because
when
I
that
saw
came
it,
from,
I saw her name and it says a survey. That's why I did it.
yes, but it actually came from Miss Becker's supervisor.
Yeah.
Okay, so the one who know if they got it is her supervisor.
I was
Yes,
just
Miss
speaking.
Barbara, because
Miss Becker, is there any way for you to know if the person's survey was completed?
No, I think the only person who would know that would be back at 11, like Diane.
Yeah, like
maybe.
Diane, right?
Yeah.
Because Mercedes, she submitted hers, but then it came back again. So
because when I finished, she gave me a hook stick and say congratulations.
Oh, so you got that when you finished? You got
Yes,
that?
when I finished, I got the indication that I did all of it and I answered all the comments. I commented.
So when did it come back again to do it again?
Like yesterday, I saw it pop right back in. I said, but I did it already. It was something wrong when I didn't get it.
It might be an error in the system.
Okay, so I'm gonna send an email to, I don't know if Rebecca is still doing, I don't know, but she's the person I will contact in any event, Rebecca and Diane, and ask them why that happened. Because if you completed it, it shouldn't pop
ask for a
back up
second
for you.
time. It should
Yeah.
record that they did it already. Yeah.
Do you mean that you went, another email came to you asking you to complete it?
Yes, asking to do it because I haven't done it.
Did you do it again? Did you repeat?
No, I no, I didn't. I feel,
Okay.
partial.
All right, I'll send
Just want
Diana
to know
a
if
text.
I got it. She saw my name and that I finished it, and I know I completed it.
Okay, all right. I'll let them know. Okay.
Maureen, make sure you complete yours, Maureen, after that session, okay? Just a link. You click on the link and answer like 5 or 6 questions, okay? Really quick, less than 5 minutes.
Hi, Miss Barbara.
Hello, Alva. Can you hear me?
I'm hearing you now, but
wonderful. Okay.
I'm using my phone. I don't know what happened to the computer.
Okay. Can you see the screen on your phone?
Yes.
What do you see on the screen? No, Alva. I want Alva to tell me, Maureen, because she's on her phone and I want to.
Yeah, GED topic schedule.
Okay, so you see, okay. Now, before we go to this, Alva, did you get the survey from Ms. Beckles? She sent you an email for a survey from 1199. Did you get it?
Yeah, she sent it, yes.
Did you do it?
No, Miss Barbara, no.
Okay, so after this session, make sure you do it. It's really quick. It's only 5 or 6 questions, okay?
Okay.
It's very important because they want to determine whether we continue on our Zoom platform or whether we go back live. Okay, go back
To the learning center.
back to the learning center on Elm Place, okay?
Okay.
So
All
we
right.
know everybody has an opinion on that. That's why they want to hear from everybody, because based on what persons respond to, that determines whether we continue or whether, and this is for the fall coming up, or whether we go back to our
Yes.
location, okay? All right.
But it's nice this way because we stay in our home.
You're right. You're right. Yes, when we had that really bad weather, I said, I'm really glad we're doing it online. Nobody has to try to trudge out in the snow and get us somewhere in a bus or drive or whatever. Okay.
Yeah,
All
like
right.
me in the Bronx.
Okay, so this is what we'll be looking at. As I said again, the homework, radicals and exponents. We'll do some more on that. And then we'll look at scientific notation. So let's go to our homework. Let me do a new share. And I want to go to homework. You see the radicals practice homework?
Yes,
Yeah.
miss.
Okay. Now, Alva, did you got this homework, right?
I got it, Miss Barbara. I work with a few, but I don't know if I get it
Okay,
right.
all right. Let's go to number one, Alva.
Yeah. Just
You
a
have
minute.
okay, you have it, or you can just look at the screen.
Okay. Number one.
Number one, which property is used? This is a division, right?
Yes.
So which one of these properties match that division? 1, 2, 3, 4, or 5?
Okay, let me pick it up on this.
Okay, Albert, look at number one. That's a division. It says 2 to the 12th divided by 2 to the 8th power. Which
Yeah.
one of these properties, 1, 2, 3, 4, 5, is a division of powers?
Well, I would say it's the first one.
Division. Look at it again, Alva. Remember, dot represents the multiplication. Could be a dot, could be an X, and the reason they put an X here because they're already using the variable X, right? Or it could
Yes.
be an asterisk, or you could have put them in parentheses. Now that's a multiplication.
Yeah, because
Multiplications give you products, right?
yes.
What do you do when there's multiplication of powers, Alba? What do you do? What do you do to the powers?
We have to add and then
Yeah, you add right here. It says
yes.
n to the n times n to the m. You
Yeah.
add n plus m. And if you
Yes.
put numbers there, you see 2 to the 3rd times 2 to the 5th, add the 3 and the 5, you get 8. Now that's a multiplication. Now, which property used is the division property? One, two, three, four, five. Which one is a division of powers, Alva?
It would be number 4.
No, Alva, look, you see what this says? What
Yes.
does it says? 2 to the 12th
Yes.
divided by 2 to the 8th.
Yes.
Which property says a variable raised to a power divided by the same variable raised to a power? In other words, same base.
Mm.
2 to the 12th divided by 2 to the 8th.
Okay, so it would be 5. Huh? Number 5.
No. Does that look like this one? See, number 5 says variable over variable. In other words, base over base, they're different. The whole quotient is raised to a power. Quotient is what you get from division. That's not
Yes.
what this says. You don't see anything in parentheses up here, right?
No.
So look at them again. Tell me which property in this list looks like 2 to the 12th divided by 2 to the 8th.
Oh, it's number 3.
That's a multiplication, Alba. Look. N x to the n raised to the m. That's a power raised to a power.
Okay.
Which one is a division? Numerator over denominator.
Okay, well, division here, as I'm looking into the numbers here, is 2.
That's right, number 2. Number 2 looks exactly like this, right?
Yes.
The 2 is the x, the n is the 12. The
Yes.
2 is the x, the m is the 8.
Yes.
All right, so
Yes.
this is a division. And the
Yes.
only division ones here are 2 and 5. But the difference is number 5, you have different bases, x over y.
Yes.
Right?
Yes.
But
That's
number, see, there's a base 2, power 12, power 8. Look here,
yes.
base x, power n, base x, power m.
Yes,
All right.
ma'am.
So your answer would be what, Alba? What would be your answer?
It will be number 2.
That's it.
Yeah. That's
Any questions on that one?
Oh boy, my phone messed up again.
Answer 2. That's your answer. That's the only one that looks like 2 to the 12th divided by 2 to the 8th. Maureen,
Yeah.
you had that one correct?
Yeah.
Okay. All right. Let's go. Yes, you had that one right, Mercedes. Okay. Now, number 2, Maureen, what is the answer?
B.
How did you get that, Maureen?
I add the 3 and the 3 and the 2, which is 5.
That's it.
And that is the bottom is the same.
Okay, very good. Now look at this, Alva. 5 to the 2nd times 5 to the 3rd. Which property?
Excuse me, Miss Barbara, I messed up again.
Okay.
I don't know what happened.
Can you
hear you, but I cannot see the work
oh, you can't see the screen?
because it's a little thing and it turned black and
Okay, so you can't see the screen.
You have to set the phone down, and because it was the least
I'm
touch.
trying to open it, but it not. Hello?
Hello?
Hello? Yes,
Mercedes say put the phone down.
that's what I did.
So you have to
Okay.
go out and come back in again for it to pick up the picture.
Yes, that's what happened. I have to turn it off.
And go back in again.
Just
Okay.
touch close and go out and come back in.
Okay, Mercedes, number 2, 5 to the 2nd times 5 to the 3rd. Which property does that represent in the list 1 through 5?
Your list.
Huh?
I can't
Is
see your list.
Right here on the other side. You don't
I
see
see
it?
the question. Oh yeah, I see it. Sorry, they're going
Right
the other
here.
side.
It's on the other side.
Yes, it's so small.
Yeah.
It's on the right side or the left of me. The one we just did is on my left, but I don't see the next one. It was on my right a while ago. I don't see it now. It's disappeared.
You don't see this list of properties that were in number 1 that Ava just did?
Oh yeah, but I thought you're doing number 3.
No. But I asked you a question.
Okay.
We did number 2. Maureen did it. Now I ask you 5 to the 2nd times 5 to the 3rd. I'm asking you which property is used for this. Yes.
Okay, let me look at it.
Which property?
Let me see. Okay, I can. My phone is so easy. I can zoom it up without you zooming.
Can you see this list over here?
Yes, I'm looking. Give me a sec, please. 5 to the.
1, 2, 3, 4, or 5.
Okay, 1 second. 5 to the.
I put here property. What property? 1, 2, 3, or 4, 5.
1.
Property 1, very good. Because property 1 is a multiplication, right? X to the n times x to the m. Add the powers, that's x to the n plus m, which is what Maureen just said she did. She added a 2, added a 3, and she got 5, and that's why her answer is B.
Yeah.
Now, Mercedes, I think you missed this one.
Number 4 is I couldn't.
Number 3, what is the property for number 3?
Hold on a minute. What we just did a while ago? I thought we just did number 3.
No, we just did number
I do
2. We
too.
didn't do 3. Maureen did number 2. So, Maureen, what property?
Wait, let me have
Well,
my-
Number 3?
Wait, I'm asking Mercedes, Maureen.
Okay.
Miss
all right.
Barbara, I'm a bit mixed up. I know I get the answer for number 1. That's 2. Number 2 is B, right?
We're
Yeah.
at number 3. What is number 3? What property, Mercedes?
I think I told you 1.
Yeah, but what is it now?
What? Don't get you.
What property is used for 2 times 3 raised to the third? That's a product raised to the third, because product is what you get from multiplication, right? Equals 216. Which property do you see here for that? Which number? You didn't tell me the right one. You gave me let's see. I don't have your list here, but I think you gave me
Oh, you're on the third one, Miss Barbara.
which one did you say, Alva?
The third. Which property is used?
Yes, which property is used?
You want me to
Albert,
answer you now?
Yes, Mercedes, which one?
4.
Number 4, but that's not what you gave me.
I know I didn't do one of them. I think it's number
You
4.
gave me another number, and I said, oh, why did she give me this one? Let's see. I
What is
have,
number 1? I miss some mix up here. I have
let
number.
me, I put down what you gave me. Let's see.
I have it on the my paper looking at the answers. So
You look, I sent it back to you. You sent it to me and I corrected it, sent it back to you. But
Okay,
you
I
gave
don't
me
get
a different number. You didn't give me the property. Okay. Let's see, where did I put it?
For-
Okay, hold on.
Okay, excuse me, Miss Barbara, you did the second one? You did it already?
yes.
Yes, did you get that one right, Alba? Let me go back to the second one. Okay. Maureen did that one.
I did it, is it C?
You add the 2 powers? What's 2 plus 3, Alba?
This is the second, you're on the first one. here
Number
now.
2 now. I'm looking at number 2 now. That one you said you didn't see. Okay. So
I'm not picking it up.
multiplication, add the powers. 5 to the second times 5 to the third equal to 5 to the 2 plus 3, right? What's that
Yeah.
equal to, Alva?
I'm not picking it up on my phone.
Oh, you can't see it.
Oh, number 2, okay.
That'd be
Yeah.
2 plus 3.
3,
All
That's-
right. And what's 2 plus 3, Alva?
2 plus 3 is 5.
5. So the 5 to the 5th power will be the answer, and that's answer B.
Okay,
Got it?
yes,
You just multiplication, you add the powers.
yes.
Questions?
The next one was number 2, Miss, right?
Yes, I went back
So-
over
so-
it for Alba.
So number 3 answer would be then 1.
Albert, let me ask Albert. Albert, you had any questions on number 2, that multiplication?
No, Miss Barbara.
Remember multiplication of powers, you add the
You
powers, right? They must have the same base though.
Yes,
See, the base is 5, same base. One
Yes,
has a power of 2, the other one has power of 3.
yes,
You add them. And if they were negative, you still add, but remember when the powers are different, you subtract.
yes.
All right. Now we're going to number 3. Now, Mercedes, I was looking, you gave me number 1 as the answer.
And
When
what
you-
if I mix number 1 with number 4? Because I know I didn't do one of them.
Okay, so
This-
what answer you saying now, Mercedes?
Can I maybe say what's the question first before I can realize what I did?
Okay,
What was it? For number
okay.
3.
2, let's look at which property is used. That's 2 times 3, all in parentheses. That's a product, right? Multiplication gives you a product, and that's raised to the 3rd power. So which one would that be? I'll say this.
I'm not getting number 3 on my phone. You went down to simplifying.
Okay, but it's on the other side,
On your
Alva.
left.
You've got to, can you scroll right and left
I
on your phone?
Okay, miss. This is the one I said number 1 was the answer.
Yes.
I
yeah,
got
Miss
that.
Barbara.
Got that right.
Yeah.
What is the answer, Mercedes?
Number 1.
It's not number 1.
Oh, so then what did I mix up?
No. This is base to a power times base to a power. In parentheses, this is a product 2 times 3, all raised to a
Okay,
power.
the answer
That's not
is
the same
4.
as this. That's
answer
right.
is
The answer is 4.
4.
Where you have x, this is parentheses here, x times y, all raised to the n power. Your x is your 2, your y is your 3, and your n is your 3. Got it?
Yeah, I know the answer, but I mixed it up, so I lose out on number 3.
Yeah. Okay. So the answer is 4.
Yeah.
This is a product raised to a power. Because when you say x multiplied by y, that's a multiplication. And what you get from multiplication is called a product, right? So a product raised to a power. And that's different from saying base to a power times base to a power.
Yeah, I got it.
You see the parentheses? That's the difference. See the
Yes.
parentheses here?
The only
Parentheses
thing is
there?
because one side of the parenthesis is kind of pale.
Yeah,
That's
and well, that's what I indicated that before. That at parentheses, you don't see it so well, but there is a parenthesis there. And plus, if you look over here, you see it, right? When you put the numbers in, it looks just like this one, right? 3 times 5 raised to the 7th.
Yeah.
Got it?
This is a good observation, Miss Barbara.
Yeah. Question, Mercedes?
No, thank you, Miss.
Okay.
Try
Now,
my-
okay, let me do this. Okay. Suppose I had, and I want to give you a problem here. Suppose I gave you this. I said 6 and okay, and I want to put that over, let's say 7. Right, and I don't need the underline there. And let me just put parenthesis and parenthesis. Now, this parenthesis, okay, let me do it like this because I want to make sure you know the parenthesis covers the whole thing. So let me use the slash. Okay, take the underline out. Okay. Take the 7 out. And then I want to put a power on here. Okay. Maureen, what property does this represent? Maureen, are you there?
Right here.
Yeah, 6 divided by 7, all raised to the 5th power. What property? 1, 2, 3, 4, 5.
I don't know. 5.
5, yes, of course you knew. Yes. Yeah, you're 6. I used the slash here so I could get the parentheses around the whole thing. So 6 divided by 7, all raised to the 5th. The 6 is your X, the 7 is your Y, and the 5 is your N. That's a quotient raised to a power, because when you do a division, the result is a quotient, right? Any question on the properties?
You know, for the first time I'm studying this property, miss. I didn't get a chance to.
Oh,
Yeah.
okay. Yes, because that's how you solve your exponent problems, knowing the properties, knowing that when you multiply, you add the powers. When you divide, you subtract the powers. When you have a power to a power, you multiply. Like number 3, that's a power raised to a power. So you multiply x to the n raised to the m, you multiply n times m. Notice 5 to the 4th raised to the 3rd, 3 times 4 is 12. All right.
When I was miss,
Yes.
oh my gosh, she asked which properties, what should I do? What do I do this all for stuff on me? So, like if I said, look one by one. And I did. I said, oh, I see.
Yes. It's important to understand the properties because that's how you solve the problems. You look at the problem, which format does it fit? What operation do I do? And then you do the operation. Any questions on properties of exponents?
Oh, thank you, ma'am.
Alva,
Yeah, Miss Barbara.
what is, let me put it, 15, and I want to raise it to a power, okay? I'm sorry, 0. What would be the answer, Alva? 15 raised to the 0 power.
It would be just 0.
No. I gave you a rule when the 0 is an exponent. What was the
15.
rule? Anybody remember? When you raise any number to the 0 power, what do you get?
A 1.
1. Alva, did you say that? Yes, very good. Any number raised to the 0 power is a 1. It doesn't matter.
To the first power.
No, not to the first power, just equal to the number 1.
Yes.
15 to the 0 is 1. Minus 15 to the 0 is 1.
Yeah.
100 to the 0 power is 1.
1. Yes.
All right. So if you had 2 numbers raised to the 0 power, you'd have 1 plus 1 equal 2.
2. Yes.
Right? If you were
Yeah.
adding 2 numbers raised to the 0 power, you'd get the sum of 2. 1.
Yeah.
Like 15 to the 0 power plus 5 to the 0 power would be 1 plus 1 equal 2. Got it?
Okay.
So remember that 0 rule. Doesn't matter what size the number is, you get 1.
Okay.
Questions? Okay, because I will be giving you on your next homework some exponent problems that I want you to do where you have to apply these rules, okay?
Okay,
It'll be
Miss
straight up problems. They won't be word problems. I just want to make sure you can apply the rules. Okay, so that was what, 3?
Yes, miss.
Okay, Mercedes, you left this one blank.
Number 4.
I wonder why.
Oh, number 4. I couldn't. I tried.
Sure, you can figure it out, Mercedes, and I'll tell you why.
It's right in the picture though, miss. You have to bring it down a little bit.
Well,
You're right.
Yeah.
Up here.
Yes.
okay. Can you see it? Number 4?
You bring it down. When you're coming down with it now.
I'll make it bigger.
No, if you make it bigger, it's still behind your screen. It's right, 3/4 of it is in your screen on the right side to us.
Okay. Let me, okay, so you need it down further. Okay.
Yeah.
Can you see it now?
Yes.
Okay. Now, Mercedes, you know this one. What's the rule for multiplication, Mercedes? What do you
is
do with the exponents when it's a multiplication?
exponent? You
Remember your properties. Look over at your properties. Look over here. Here's a multiplication. What do
yes,
you do to your powers when it's a multiplication?
you add them.
You add them.
Yeah.
So 6 plus x would be equal to what?
Oh, 6x.
No, 6 plus. I didn't say times.
Oh,
So the power of 6 and the power of x will add up to the number you see on the 3 here, and that's a 10. So what is x,
wait a minute.
ladies?
Oh, so x is 4.
That's it. I told you, you knew it. Right?
And cause
X equals 10 minus
I know
6
why I know why I didn't get it.
equal 4. And when I saw that question mark, and I said, why does she have a question mark here? I know she knows this.
I know why I
Okay.
didn't get it.
Why?
You flip the answer sign to the left, and I'm using it on the right. So I'm
But
just like,
but it's the same thing.
like
Aren't they equal?
it's like a different math. It
But
seems like a
aren't they equal whether it's left or right?
yeah, but I didn't think of that at the time.
Yeah, you gotta be flexible on these things because they're not always the way they appear to be.
Okay,
Because it doesn't matter. 3 to the 6 times 3 to x is 3 to the 10, or 3 to the 10 is 3 to the 6 times 3 to the x. Maureen, did you get that one right?
Yeah, Miss Barbara.
Okay, so because whatever x has to be added to 6 to get 10. Okay, so x is 4. Got it?
yes,
Mercedes, you understand now, right? And that's why I told you when you said you didn't understand that. Of course you do. You knew the property you use. You know you add the exponents when you're multiplying. So you say, well, I've got to add 6 to some number and get 10.
yeah.
What is that number? Can only be 4.
I thought you said it because you said like that. You're gonna do a completely different type of math.
But it's still a multiplication, right?
Yeah, I know.
Same base 3, power 6, power x. 6 plus x equal 10. What is x? 10 minus 6. Got it?
Yes, thank you.
Okay, so the answer here would be 4. All right, let's go to number 5. Now, I gave you some problems to simplify. Maureen, did you do number 5? Square root of 192?
Yeah,
What did you get?
I get 8.
Okay,
Okay.
What you
and
said,
that is correct. Now, okay, Maureen, you got A. Tell me how you got it. What 2 square roots did you multiply to get square root of 192? How do you factor this? How did you factor this radical?
I do factor that. I do it on my let's call it my calculator.
This is a non-calculator problem, Maureen.
But I do it on my calculator.
So how do you do it? This is not a calculator problem. So how do you do it, Maureen?
I went the second, the square root, put in 192, and press enter, and you get that number.
No, Maureen, this is not a calculator problem. So how do you do it? No calculator. two radical factors are there for 192? Okay, let's do it this way. Mercedes,
Yes, sir.
192. What are two factors that multiply to give 192? Try to give me one that has a perfect square root.
Oh,
192 equal what two factors?
192 equal what factors?
What two
Uh,
numbers multiply to give 192? And one of them is a perfect square root.
Okay, 16 or 12. Should I give it two number?
16 and 12.
Yeah, 64 and 3, Miss Barbara.
That's it, Albert. Thank you. 64
Barbara, hold a minute, Miss Barbara.
times
I-
3.
Miss Barbara,
Yes.
I thought you said Maureen was right with A. So I'm saying, wait a minute.
Maureen is right with A.
So I have this answer right. I have C for my answer.
No.
I don't
When you when you simplify Mercedes,
yeah.
you don't leave any number that can be factored. So it can't be B, C, or D because all three of these numbers can be factors, right?
I misunderstood something completely right there. I missed something completely. I know that if you divide 192 by 16, you get 12. And if you divide 192 by 12, you get 16. So I don't understand.
Well, if you put 64 and 3, right?
Yes.
Okay, so if you put, let's just put square root of 192, and let's put our square root of 64 times the square root of 3. So let's put the 64.
Oh yeah, 64 couldn't work.
Okay, and now let's put our square root of 3. Now, if you broke this down to square root of 64 times square root of 3, what's the square root of 64?
The square root of 64 is 32. Am I getting it right?
Square root of 64?
I was saying 32.
No, the square root of 64 is a number that
Oh,
multiplied by itself to give you 64. So that would be what, Mercedes?
that would be 8.
Okay, so let's just put that there. Square root of 64 is 8. So then we put an 8 here for the square root of 64. And that's your answer.
So why the 3 then?
Why the one?
I don't remember why the 3. That's why maybe that's why I didn't choose it.
Because you have a 3 right here. Square root of 3. See, remember that we factored square root of 192. Alva said 192 factors into 64 and 3, right?
Yes, I agree with that.
So then you put square root of 64, square root of 3. Square root of 64, a number that multiplies by itself to give 64, and that's 8.
I don't
Okay,
understand the 3's in.
question?
I don't understand the 3's in it.
But you can't throw away the 3. Square root of 192 is equal to multiplication of 2 square roots, right?
Yes.
It's like you factor in the radical. So the radical 192 factors into the radical 64 and the radical 3. Now, when I say radical, I'm referring to the radical symbol and the number. Remember, the number inside the radical is called a radicand. All right.
Yeah.
But when I say radical, I'm referring to the symbol plus the number in the symbol. Okay.
So
So go ahead.
why couldn't C work?
I'm sorry.
Why number C couldn't work for the answers? I'm a bit confused.
Because 64, it says simplify. 64 is a number that can be factored into other numbers. All right. So plus it's not 64, it's square root of 64.
The reason I choose 64 C, because if you divide 192 by 64, you get 3. That's why I chose. So
Yeah,
on a-
but Maureen, you're mixing up things. Remember, we are factoring radicals into other radicals. So it's not
Okay.
64, it's a square root. See, when we say simplify, you're trying to take a radical and factor it into at least 2 other radicals.
Oh,
Okay. Now, if it were just a number, 192 factors into 64 and 3. But the radical square root of 192 factors into square root of 64 and square root of 3. Square root of 64 has a perfect square root. In other words, it has a number that multiplies by itself to give 64. That number is 8. So square root of 64 is 8. Now, I sent you a list of the perfect squares. Did you get it? I emailed it to you last week.
yeah, I saw it. I saw
I think
it.
maybe Monday I sent it.
I saw it, but I
You
didn't
saw
find
it, right? Yeah, because
it.
certain perfect squares you should remember. 64, you definitely should know. 49, square root of 49 is what, Mercedes?
It is 7 or 9.
It's 7.
7.
Can't be 7 or. It's only one number, right? Alva, what's the square root of 81?
Is it 9?
That's it. Very good. This is some
Yeah.
square roots you know already. What's the square root of 16, Alva?
Let me see.
Square,
16,
square root of 16.
4.
4, that's right. You think of a number that multiplies by itself and gives
Yeah.
you the
Yeah.
16. All
Yeah.
right. Square root of 36, Maureen.
Huh? 6.
Maureen, 6. 6 times 6, 36. Okay. Square root of 100, Mercedes.
50.
No, 10.
10.
Lord,
Mercedes, 50 times 50 cannot give you 100.
that's my problem. I am mixing up. I am mixing it up because right away I'm just saying.
No.
Taking answer.
You got to give me a number, Mercedes, that multiplies by itself to give me that square root number.
I don't know why I mixed. Now I understand why you use A for the answer.
Okay.
It's not like I don't know the facts. It's just like
Mercedes, square root of 144.
square root of 144. Maybe I know it in my head.
You should know
12,
that.
12.
12, of course. You know your 12 tables, 12 times 12 is 144.
It just kicked back in the head. I said 12.
See, there are a lot of them you know already. You really do. Trust yourself. You know them.
We know some of them, Miss Barbara, but as we get older and so much responsibility.
No, Alva, what's the square root of 25, Alva?
5.
See, you know them. Tell
You know what I found? You know what I found out, Miss?
What?
Doing these radical and so on, really kicking back the timetable, really the timetable in our head really quite easy. That's what I found out.
Yeah. Yep. Yep.
It's a smart way to do the timetables back to your head and stay.
Yeah, I tell you, that's a good foundation. I
But,
mean, they're
my
not,
problem is when I see the 8 and I see 3, I said, but 3 8 is 24.
but you got to think radicals factored into radicals, Mercedes. Radicals factored into radicals. All right. Now, let's take this one. Okay, I'm gonna put another one here. Maureen, no calculator. You hear, Maureen?
I
Mental,
hear you loud and clear, Miss Barbara.
mental math,
Okay.
Maureen. On the GED, they would not let you use a calculator on this problem. Okay, let me just put this here. Okay, somebody want to give me the answer? Mental math. Have an answer? Square root of 48. What two factors of 48? One with a perfect square. Mercedes, you know them?
Not straight out of my head, but I remember that one.
Okay, let's see. You know them. Think of two numbers you multiply, and I'm going to put this here. And you tell me what the numbers are. This is, let me just put this. Okay, I want to put this. And I'll put another one here, and you just tell me what goes in the radical. Okay, so I've got the radical symbols here. What two radicals factor into square root of 48? One is a perfect square root. Just think of factors of 48. What two numbers can you multiply and get 48? I'll say these.
10
10 is not one of them. Mercedes, 48 equal what?
I'm trying to figure it out, Miss.
Two numbers you multiply and get 48. Mental math.
24 and 2 or something like that.
Okay, 24 times 2. Does either one have a perfect square root?
I think so.
What's the square root of 24?
6.
What?
Oh no.
You know a number you multiply by itself and get 24? I don't. You know a number you multiply by itself and get 2?
1. 2 ones is just,
By itself, Mercedes.
oh,
2 times 2 is 4.
okay.
Okay, give me two more numbers. 48 equal what? Maureen, you know two numbers?
4 and 12. 4 and 12.
4 times 12. Okay, and 4 has a perfect square root, right?
Yeah.
I didn't want to use 12, Miss. I could give you that, but I didn't want to use 12 because I
Yeah,
used to say 2.
well, it has a perfect square root, but now 12 can be
12
factored into 4 and 3. So
Oh,
you could factor that again, right?
yes.
I mean, it will work, but you'd have more than one step. Now, Maureen, give me another factor, set of factors.
What?
What would you give me, Maureen?
3
Okay, 3 and
and
what?
16.
That's it. That's the one you want to give me. Okay, because 16 has a perfect square root. That means I can put a 16 under this radical right here. They'll say, did you follow it? We put the 16. And the reason I'm putting it first, because it has a perfect square root. and then I put a 3. Got it?
Mhm.
What is that equal to, Mercedes? Let me just copy that. What's the square root of 16?
8,
Square root
No.
of 16
4.
is 4. So this becomes a 4. Square root of 16 is a 4. And that's the answer.
3.
4 times the square root of 3. Got it?
So you do that now. It's the 4, 4, 16. Oh, now we come right back. 4,
You
4,
got
6
it?
times 3 is 40. Oh, Lord.
Okay, see, now that's the simplified. Now, the number, like you gave me the 4 and the 12, I think. Who gave me 4 and 12? But 12 also has a perfect, has factors 1 with a perfect square root, because 12 is equal to 4 times 3. So you'd end up with the same answer, but you'd have to do 2 steps. Got it?
So when I see it like that, like A up there, if I had saying 8, 8, then I'll get the answer for 192. Oh,
Yeah.
now I know what next
Okay,
time.
so you break it up into 2 radicals, one with a perfect square root. But you try to take the largest of the factors, because if you could take smaller, but the thing is, you'll just take more steps to do the problem.
I got that.
It would work. It'd just be two
Because
couple of
8,
steps.
8 for the answer A up there, you say 8 times 8 is 64. Multiplied by 3 give you 192.
That's
Just
right.
like the bottom. At the
That's it.
bottom.
Yeah, just like we took 192 and factored it into 64 and 3, we took the square root of 192 and factored it into square root of 64, square root of 3. Square root of 64, perfect square, 8.
Okay. And the
And
bottom say 4, 4, 16.
that's right.
Times 3, 40.
Yeah.
Oh,
So
good
you
for that.
think, when you think of factors, think of your largest factor that is a perfect square root. Got it?
Okay. Okay, thank you.
Okay. Now that was number 5. Maureen, number 6. What did you get? Square root of x to the 4th power.
I get D, but I know if it's right.
You got what?
It says B. I don't know. I get D.
Mercedes, what did you get?
I had A.
A. A is correct. Maureen, what
Okay.
when x to the 4th factors into x to the 2nd times x to the 2nd?
Excuse me, Miss Barbara,
No,
you're
it is, okay.
saying 5?
6.
This is number 6.
Okay.
Square root of x to the 4th.
I had that at first, but I changed it.
No, but Maureen, remember, whatever you pick, you've got to add the powers and get back the 4, right? So let's just put this here. Now, to get back the 4, let's just put equal. Right? And I'll put another radical here. Now, this would have to be, and let me put one behind it. Okay. So to get a 4, what must these numbers be, these powers, to get a 4 here? What must they be, Maureen?
2.
2. Yeah, these would have to be 2, right? 2 and a 2. Okay. So square root of x to the 2nd times square root of x to the 2nd gives you square root of x to the 4th. So so x to the 2nd times x to the 2nd gives you x to the 4th. Yeah, Maureen, Mercedes had that one correct. So answer A. Now D is a negative.
Yes.
Okay, so you'd have square root of x to the minus 2 times square root of x to minus 2, which does not give you x to the fourth. That would be x to the minus 4. Okay, because you'd add the two powers. Minus 2 plus a minus 2 gives you a minus 4. But that's not what you have here. You have a plus 4. Got it?
Yes. And
Number,
it's so tricky.
yes,
You
yes.
said that, Miss Barbara.
What did you say, Alva?
I say it's tricky. You said it like that to trick us.
No, not really. It's not to trick you. Because remember what your properties, you
I know.
add the powers when you're multiplying, right? So
Yes.
if you have a 4, what two numbers add up to 4? 2 and 2.
2. Yes.
So you just look at your possibilities. 3 and 3 would be 6, right?
Yeah. And
1
you have
and 1 would be 2, minus 2 and minus 2 would be minus 4. So the
Yeah.
only ones that add up to 4 is x to the second, 2 plus 2. Right?
Yes. Yes.
Got it?
Yes, ma'am.
Okay, number 7 was a subtraction. Mercedes, you said minus 80. How did you get minus 80?
Miss, you see that one, Miss, is a guess answer. I'm not sure.
No, no, no. What do you do when you are subtracting radicals? You only look at the coefficients and you subtract them. So, or an
I
8
look
and a minus 10 is equal to what, Mercedes? What's 8 plus a minus 10? Let's just put that here.
at 8.
Okay, so you're adding up the coefficients. So it'll be
Oh,
8
okay.
plus minus 10. What's that equal to, Mercedes? Remember your law of signs? What is that equal to?
That will equal to 2.
Plus or minus?
Minus 2.
That's it, Mercedes, minus 2. So then the radical stays the same. So that means your answer would be a minus 2 times the square root of 3. Let's just put that there. That's your answer. So which answer is that, Mercedes?
That answer should be C.
That's it, answer C.
I can't believe it.
So I was wondering, how did you get the 80? How did you get 80 minus 80?
I didn't even look at it the way you showed me.
Probably she multiply.
I know she multiplied, but this is a subtraction. And adding radicals, subtracting radicals, you only add or subtract the coefficients, never multiplication. You only multiply if you are multiplying the radicals, but this is a subtraction.
Yes.
So you just add a plus 8 and a minus 10. That gives you a minus 2. So your answer is C, minus 2 times square root of 3. Remember yes, Alba.
They put another one there to trick us.
Which one?
Yeah, miss the sign. That's what fools me. That
Yeah.
fool, you have 3, 2,
They
3 on.
put a positive and a negative.
Yes, but if you know your signs, Alba, what do you do when your signs are different, when you're adding?
You subtract.
That's it. Thank you, Alba. You subtract, and then you use the sign with the number that has the great absolute value. That's a 10. So that means your sign is negative. Or you look at it, if you got more negative than positive, your answer will be negative.
Negative, yes.
Right?
Yes.
And you certainly have more negative, 10
Negative.
negatives and 8 positive.
Positive.
So your answer would be a negative 2. Always a subtraction when you're adding unlike signs.
Yes.
Okay?
Yes, ma'am.
So you remember how to add radicals and subtract radicals, right?
Yes.
Okay. Let me
Maureen
just...
is right. I multiply. I say 8 times 8.
No multiplying here, Mercedes. Only if you multiplying radicals, but we were just dealing with adding and subtracting. We haven't gotten into multiplying yet. Now let me put an add here. Okay. I want you to add, let's see, this is a 2. And this is 5. Remember, you can only do this if the bases are the same. Okay, that's a 5. I want 2 times the square root of 5. And I want plus, this is a plus, I'm adding here. Alpha, what's 2 times the square root of 5 plus 10 times the square root of 5? What is that equal to?
2 times
The square root of 5 plus 10 times the square root of 5. What is that equal to? Add the coefficients.
Oh.
Coefficients, the numbers in front of the radical. 2 times square root of 5 plus 10 times square root of 5. What's my answer, Alba? 2 and 10 are your coefficients. So what are the answers?
2 times square root of 5.
Plus 10 times the square root of 5. What's the answer?
Miss Barbara, that one.
No, you can do it, Alba. Add the coefficients. The coefficients are 2 and 10.
Okay, it's 2 and 10.
As
Yes,
the what? What is 2 plus 10?
12.
12. So now you've added the coefficients, and then you just put the radical, square root of 5. That's it.
Okay.
Got it?
Yes, ma'am. Yes.
Okay, so you add the coefficients. The coefficients are the numbers in front of the radical.
So all we
Yes.
need to focus, Miss, is on the signs. The signs.
Yeah, you have to remember your sign rules, but you're always adding or subtracting the coefficients when you're adding and subtracting radicals.
Yes.
Okay. Now
And
this
the
works when the
coefficient is
base.
one.
Yes, Alva.
No, I said the coefficient is the one always on the right.
No,
So,
it's
Miss
the
Barbara,
no. The coefficient is the number in front of the
That's
radical. Just like if Alva, just think this. Suppose you had 6v plus 8v. What's that equal to, Alva? 6v plus 8v.
Okay, so you're gonna do the 6 and the 8.
Yes, and that gives you what?
And that's 14.
That's right. So you'd have 14v.
Yes, 14B.
That's
Yeah.
right. So the v, instead of v, the variable, we use the radical. So it's the
Yeah.
same thing.
Same
You
thing.
just add the coefficients and then write the radical, just like you add the coefficients and then put
Yeah.
the variable v.
so Miss Barbara,
Yes.
if you had a 5 and a 6, what would you do with the bottom? Then you got 2 to 5, 10 to 5. So now you had 2 to 5 and 10 to 6. What would you do?
If I had one,
If you had a 6 here by the 10, what would you do? Because the coefficients would be, I think the radicals would be different, right?
okay. So tell me what to write, Maureen.
Okay,
You
If
want
you got-
to you want to take the same thing right here, right?
yeah, but move, put a 6 by the 10.
A 6 by it or 6 in place of it?
6 in place of the 5.
Okay.
Yeah.
You mean the
Yeah,
radical?
right there. Yeah,
You
radical,
mean put a 6 here?
yeah.
Yeah, that's what she's saying.
Okay.
Okay.
Remember, this could work, but you'd have to get the square root of 6 and multiply by 10, get the square root of 5 and multiply by 2. This only works when the radical, the radicand, that's the number under the radical, the same.
Oh.
You can't
Okay.
add 10 and 2 and get 12 here. Thank you, Maureen, for pointing that out. You can't say 10 and 2 is 12 and then say 5 and 6 is 11. No. It only works when the radicand, that's the number inside the radical, is the same. Now, you could solve this, but you'd have to get the square root of 6. You do that on a calculator, multiply that by 10, get the square root of 5, multiply it by 2, and then add those two and get a
Oh, I
number.
see.
Okay?
Oh, okay. Yeah.
So this adding and subtract the coefficient. And thank you for Maureen for that example, because you can't add coefficients unless your radicands are the same. Radicands are the numbers in the radical, like 5 is your radicand, 5 is your radicand. Got it?
Yeah.
Okay, now let's do new share. And let's see if I can bring up my new session discussion. Okay, do you see the exponents and roots?
Yes, miss.
Okay, all right. So we're going to look some more at these. I think we went through these, but I think only Maureen was on. But okay. Just some of it is probably review for you. 4 to the third power is 4 raised to the third power. Now notice when you use the exponents, the number gradually increases. Now over here, this little caret means raised to that power. So 4 to the 1 is 4. 4 to the 2, 4 times 4 is 16. 4 to the 3, yes, Mercedes.
First part of that table you're showing us is covered by your picture.
Okay,
It's
so,
right on.
all
yeah.
right, so let me just bring this down. Okay, can you see it now?
Yes, much better, thank you.
Okay, all right. So 4 to the second power, and 4 times 4, 16. 4 to the third power, 4 by itself 3 times, 64. 4 to the fourth power, 4 times itself 4 times, 256. 4 to the fifth power, 4 by itself 5 times, 1024. So you see how quickly your values increase. All right.
Okay.
Now, I have some laws of exponents, and we've gone through some of them, but I just want to emphasize, we said that any number to the 0 power is 1. A number to the 1 power, you get back the number of variable. So 6 to the 1 power is just 6. 100 to the 1 power is 100. Okay. 0 exponents always give you 1. Negative exponent is reciprocal. So x to the, okay, 3 to the minus 5 is 1 over 3 to the positive 5. So if you have a negative exponent, you write the reciprocal. In other words, turn it upside down and put the positive exponent. The product rule, we went through those, add the exponents. Quotient rule, that's the division. Power rule, we went through that with properties. You have a power raised to a power and you multiply. Now, remembering these laws will help you when you solve your problems, right? Now, this, I'm just giving you, I'll send you all of this, but this is just an explanation of what I just went over. Okay.
Thank you.
Okay. Now, there's a multiplication. You had one for your homework. 8 to the third times 8 to the second, 3 plus 2, 8 to the 5. Division, 9 to the 7th divided by 9 to the 10. Remember now, this is 7 minus 10, so you get a minus 3. And there again, 9 to the minus 3. So when you have a negative exponent, you put it reciprocal. That's 9 to the minus 3 over 1 is 1 over 9 to the plus 3. Any questions about negative exponents?
This one a little new, so I have
Can
to
you
study.
explain that one that you know, give us?
I'm sorry.
The 7 is 9 to the 10.
What's, okay, 9 to the 7th over 9 to the 10. So let me just write that out for you. Okay, let me just put that. Remember, you subtract the exponent of the denominator from the exponent of the numerator. So let me just copy this. Okay, put that here. Okay, there we go. Okay, so this would be, let me just take that out. Okay, so that would be 9 to the 7th. So let me just put a 7 minus 10. Mercedes, what's 7 minus 10?
7 minus 10 is 3.
Plus or minus?
Minus.
Yeah, minus 3. So this becomes a minus 3, right? But now notice that's 9 to the minus 3 over 1, right?
Yes.
Okay, so let's just put that's over 1. And let's put a 1 here. Okay. And when the exponent is negative, it's the reciprocal. In other words, turn it upside down, put the 1 on the top. So that would be equal to what? 1 over 9 to the plus 3. Got it?
I don't
So-
think I see your writing, miss. I don't see this 9 to the 7 power over 9 to the 10. Is that the one you're talking? I don't see a different. That's it.
9,
Okay.
9.
I'm saying 9 to the 7th divided by 9 to the 10. Remember, division, you subtract the exponents. You subtract the exponent on your bottom number, which is your denominator, from the exponent on the top number, which is your numerator. So that becomes 7 minus 10. And here I have it right here. 9 to the 7th over 9 to the 10 is 9 to the 7 minus 10. But sign rules, whenever you're adding unlike signs, you subtract. So 7 minus 10 is 7 from 10, a 3. 10, your biggest number, has a negative value, and
Yeah.
it's minus 3. When I say biggest value, that means absolute. Absolute value means disregard the sign.
Okay, excuse me, Miss Barbara.
Yes,
So the 10, you subtract the 10 from the 7 from 10.
right. And I
And
get a
the
negative
minus
3.
3. Yeah, because the 10 was minus. Yeah.
That's right. Just think
Yeah.
of it. If you've got more negative than positive, your sign will be negative. And you have
Yeah.
more negatives, 10 is certainly greater than 7, right? So you get a minus 3. But now 9 to the minus 3 over 1 is the same as 1. That's why I say reciprocal, just flip it. 1 over 9 to the positive 3. Remember Alva's flip it?
Yes.
Okay, just take your 1
Okay.
and put it as a numerator, put your 9 to the 3rd as the denominator, but make that 3 positive. If it's negative,
Okay.
you make it positive. If it's
Okay.
positive, you make it negative.
Negative.
Got it?
Yes, ma'am.
Any questions on the negative exponents?
Well, sometimes you get tests like this and you're wondering how to start.
That's
But
right. You're right. Yeah, because you may be given a multiple choice and they give you the answers in terms of the reciprocal, 1 over 9 to the 3rd. So you have to know the rule that if you have a negative exponent, it's 1 over the positive exponent.
Okay. Can I ask you a favor, because you know I don't talk much in the class.
Okay. Yes.
If we could work on some more of this until it's again.
Yeah.
Oh, okay. All right. So, all right, let's do another one. Okay.
I mean, now.
No, we'll do another one. Okay. Let's do another negative. See if you get it. Okay. 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 All right. Let me just put another problem here. Suppose I had 15. Okay. Let me put another exponent here. And this is a 4. All right. And I'm dividing this by 15. Same base. And let me just put this as 12. Okay, so Alva, I have 15 to the 4th power divided by 15 to the 12th power. What would be the answer?
Okay, so
You know,
the
this is
power,
going to be a
the power,
15.
the power gonna divide by 12.
This is division, subtract the exponent. So what would be my power on my 15? 15 to the 4th divided by 15 to the 12th. So what am I subtracting here?
You are subtracting you're subtracting the 4 from the 12.
You're subtracting 4
From 12.
minus, no, the other way.
Okay.
Numerator minus denominator.
Okay.
Okay. So 4 minus 12. And what's that equal to, Alva? What's
That's 8.
plus or
8.
minus?
It would be a minus.
No, you're right. Minus 8.
Yes.
That's
Yes.
it. Because you
Yes.
subtract when your
Yes.
signs are different. So this will be a minus 8.
8.
Now,
Yes.
what would it be as a plus exponent? What would it be? When I flip it, what would I have?
You would have okay, you would have a plus. No?
What's the reciprocal? You got to flip it. It's 15 minus 8 over 1. So this would be what? 1 over what?
15 minus 8 over 1.
And that would be equal to what?
15.
1 over what?
1 over 8. 1 over 15.
1 over 15 to what power?
Yeah. To the 8 power.
That's it. Very good. You
Yeah.
got it. That's it. Because now it's positive. You got it?
Yes, ma'am. Yes.
Is that clear to everybody?
Yeah.
Because you may see it both ways, you know. You could
Yeah.
be given the positive and
As well
you
as
making
the
it a negative, and then you flip the 15, you put a 15 over 8 on the top and then make it a minus. So it goes both ways. If you had 1 over 15 to the 8, that's equal to 15 to the minus 8 over 1. Okay? Just remember the flipping goes both ways. Question?
No, thank you.
All right, now let's go to the power rule.
Miss,
Another
this class go to 4 o'clock?
Question?
Does this class go to 4 o'clock?
Yes, 2 to 4. Okay,
Oh.
right in its simplest form. This is the power rule. Remember, when you look at the properties, you multiply the powers. So you have 5 times 6 is 30. All
Which
right?
one you're doing now, Miss Barbara?
Now we're looking at examples. I'm showing you the various properties. So when you have 3 to the 5th, all raised to the 6th power, multiply 6 times 5, get 30. That's equal to 3 to the 30th. Very big number.
Okay.
So you can add, subtract, multiply, divide, and simplify radicals. So we went through adding, but we just go through it again. Okay. Now, just like you add up variables, like if you had this string of variables, right? and you add up the like terms. 3x plus 5x to the second plus 7x plus 2x to the second plus 9. Mercedes, what are your like terms?
My like terms x
For this
plus
set of variables? What are your like terms here?
my like terms. All right. 3x plus 7x
That's right. 3x plus 7x, that gives you
plus
10x.
10x. Yes.
Okay.
Oh,
No, 3x plus 7x. Add
give
the
me
coefficient 3 plus 7, you get 10x. What does anything else look alike?
you have 5x to the second power plus 2x to the second power.
Okay.
Give you 7x to the second.
7x. So 5x to the second, 2x to the second. They look alike, so you can add the 5 and the 2, you get 7x to the 7. And of course, the constant only appears at once, so plus 9. There's your answer. So just like you combine terms in algebraic expressions, you combine terms in radicals. 8
Okay.
times square root of 5 plus 12 times square root of 5. Add the 8 and the 12, you get 20 times square root of 5. Subtraction, same thing. 6 as the coefficient minus the 2 coefficient gives you 4. Okay.
And
Now,
the 8.
sometimes they're not in the form where you can actually add them. You may have to get them in the order. Like this one is already in order. 2 times square root of 5 plus 6 times square root of 5. 6 and 2 is 8, right? But what about number 2? You see anything in order for number 2?
I'm not seeing the curl.
Square
6 and 6.
What do you see that look alike, Maureen, for this one?
6.
6 and what?
6.
6 what?
6. At radical 2b and plus 6 radical 2b.
Miss, can you shift it to the more to the left, to our left? We can see after
Okay, let me bring that down. Okay. Can you see it now? Okay.
no, Miss, still not still
You
there.
don't see number 2?
From left to right, we're going to see the rest of it. After
Okay, I'm on the right side. Do you see number 2?
I see number 2, but not all of number 2.
Okay, I brought it all the
Going
way
back,
down. Can you see it now?
you just need to shift back to the right to our left.
No,
Your
but
right.
this is on my right side though. I'm just
When
bringing it down.
how you see
What you say?
What do you see, Mercedes, for number 2?
after bx, after you see the last part of it, starting from the 2, go to the end of it. We don't see the end of the what
Oh,
comes
What's the first term you see?
radical b
Square, okay, okay, radical b plus what?
radical 6 radical 2b minus 5 radical b equal minus 4 radical b. You can't see no more.
The other one is radical 6.
You don't see 6?
The last one is the same. Mercedes, the last one is the same as the second one. 6 radical
You
2b.
don't see 6 times square root
Okay,
of b right here?
what I do, I just see it now. I just use my
Okay.
hand and pull the screen and it
Yeah,
moves.
you have to scroll to see it because I'm left here and now I'm right.
Okay,
Does everyone see this?
I got it.
Then
Okay.
Alva,
Well,
Yes,
Alva can't see on her.
yeah, I'm seeing it, Miss
Oh, you
Barbara.
seeing it? Okay. Now, Alva, which terms look alike here for number 2? Which terms look alike?
It's the 5 and the 4.
No, don't look at the right side.
Oh, don't look at the right side.
Okay. Okay, let me just take this out because let me take that out. Okay. Now, Alba, we want to combine these. Which two terms look alike here?
Hmm.
You have the radical b plus 6 times the radical 2b minus 5 times radical b. Do you see any terms that look alike?
Yes.
Which two look alike?
The 6 b plus 6.
In other words, you're looking for radicals that look the same. Do you see any that look the same?
Yes, Barbara.
Which ones look the same?
The B and the 2B? No, yes.
No, b and 2b are different. Do you see another b, another radical b?
Yes.
Where, what does it say?
It's a minus 5B
Okay,
radical.
that's right. So you see radical b and you see a minus 5 radical b. So you can combine those,
Yes.
right? You can take the radical b
Yes.
and combine it with the minus 5 radical b. So let's just put that
Okay.
there. And then we can take the minus 5 radical b
Okay.
because they all have the same radicand. That's the number under the radical, right? Now, okay. So what is that equal to, Alba? Combine the coefficients. You have a 1 here. That's a plus. That's the default. You have a minus 5. So what's 1 and a minus 5? What is that equal to? Alva? A plus 1 and a minus 5.
Oh, a plus 1 and
I don't hear you.
a plus 1 and a minus 5?
You sound like you're in a hall. You at your mic?
Someone calling on my phone, that's what.
Okay, you should.
Hearing me, Miss Barbara?
Now I hear you. What's a plus 1 and a minus 5?
A plus 1 and a minus 5.
What is that equal to?
It equal to a minus 4.
That's it. Very good, Alba. Minus 4.
Yeah.
You did a subtraction and you get the 5 has the sign. It's the biggest of the two numbers. And then you just put square root of b, all right? Because they're all under the same radical. So let's just put the square root of b next to it. Okay. Now the square root of the 6 and the square root of 2b is not, it doesn't have another, we don't have another square root of 2b. So we can just write that by itself. Okay. And since we combine the likes, and then we just put that here, and that's your answer. Minus 4 times the square root of 2b. So sometimes you have to simplify before you can add or subtract. So since you had here the square root of b twice, you had to combine those and got minus 4 times square root of b. So this would be your answer. Any questions? Let's see.
Yeah, we're trying to figure it out, Miss Barbara.
Any questions on that problem?
No, man.
Sometimes you have to simplify your radicals before you can combine them. And here you had two that looked the same. You had to add those together so you could finish the problem. And there's your answer. Okay. All right. Now let's go. Okay. Okay. Now I want you to simplify. I think we did this one, but anyway, simplify this radical. That means you're going to break it into two radicals. Okay. Anybody want to try it?
You mean the 98?
Yes. What does
Okay.
that factor into? We want to factor it into two radicals.
Okay.
One should have a perfect square root. What would that be equal to? Anybody want to give me factors here? Maureen, what are factors of 98? Maureen,
Okay, hold on.
give me two numbers multiplied to give 98.
49 times 2.
Maureen, are you there?
Yeah, I'm here, I'm here.
Yeah, what are two factors?
I know, but I can't call it both ways.
No, Mercedes just said it. What are they, Mercedes?
2 times 40. Yes, 48.
No, not 48. I thought you said it before. 2 times what?
49.
2 times 49. Very good. Just half of 98, right?
Yes.
So
Do that
that,
Monday.
all right. So that means you can take the square root of 98. And Mercedes, you want to make that two radicals. So what would I write, Mercedes? Tell me what to write.
You write 49 first.
Okay,
Yes.
that's right. I put the 49. Okay, let's put that there. I'm breaking a radical into two radicals. Let me put another. And that's the 2, square root of 2. What's the square root of 49, Mercedes?
That's 7.
That's right, 7. Very good. See how good you're getting, Mercedes. All right.
Yes. I just get it straight like that. I couldn't believe it.
So that's your answer. 7 times square root of 2. That's the answer. All righty. Very good.
That's what I'm telling you. Doing the maths this way, I realized that it helped you to just bring back the timetables in your head automatically.
Yes, right. That does help. I tell you, it saves you steps. Because some of the problems, actually, the new GED doesn't have many non-calculator. It only has a few. I mean, maybe about 5, I think, in the others calculator. All right, try number 2. Maureen, put your thinking cap on.
Oh,
147. What are some factors? 147. Anybody got factors of 147?
3, 49.
Let's find out if Maureen, you know 147 factors.
Oh, I thought you said anybody.
147, right?
Mercedes can help. 7 and 1.
7 and 27.
7 and 27. 7 and 27. 7 times 27. You could say 7, what, and 20, 7 and 21. But neither one of those have a perfect square root. What did you say, Mercedes?
I'm saying that wait, what should I give again?
You gave me 2 factors, 2 good ones. You said them. What are they?
I think I says, what is it? Oh, 47.
You said two factors, really good factors. One has a
I said
perfect square
I
root.
said three times 49.
Okay. You said three times 49. Maureen, did you get that one?
Yeah,
And 49 has a perfect square root, right?
yeah.
Yes.
So you take that square root of 147, break it up into two radicals. Okay, let's put out 49. Okay. And that's equal to,
3.
and let's put our 49. And we know what the square root of 49 is, right?
Yeah.
And then put our 3's. What's the answer, Mercedes?
7.
Yeah, square root of 49 is 7. So let's put equal 7. And then let's put square root of 3. That's your answer.
Yes.
That's it.
Yep.
'Cause
Got it? See,
Yeah.
the more the
times
more of
7.
these you do, the easier it comes, right?
Because if you say 7 times 7, you get 49.
49.
Times
Yeah.
Right.
3, you get 147.
That's it. Okay, square root of 42. Maureen, what are factors of square root of 42?
One is 6 and one is 7.
Okay, you say
But they're
42.
not,
7 is 42. Uh-huh.
You said 6 and 7?
yeah,
Okay, neither one has a perfect square root.
no.
You know of any factors that have perfect square root?
Thank you, Ron. And
21 times what?
21 times 2 is 42.
Neither one have a perfect square root.
No.
Any other factors?
No.
Mercedes, any other factor?
For 21. Oh, she said already, so I was
She
looking.
said that one.
I was thinking.
You say you want a perfect square root?
And any other factor? Sometimes they're none. Sometimes they are all prime numbers.
What about 16?
16?
Yeah. Isn't it a perfect square root?
Yeah, but
Not
16
42.
times 16 times something gives you 42.
No. Oh, you're working on 42.
Yes.
Oh, okay.
So
You want to
any
know-
other factors of 42 other than 21 and 2 and 6 and 7?
What about 9?
No.
3 multiplied by 3.
No, you want to get 42.
Oh, 42. Okay.
You also have what, 3 and 14. Now, sometimes you don't have factors that will give you the perfect
That's
square root. Questions?
I was saying yes, 3 and 14.
Yeah, but sometimes you don't have, say if you take 42 and you want to put all your factors, right? Let's take 42. And we take 1 and we go up to 42. Now, we said the 2, we put the 2 in, 2 times 21, right? So we put the 2 And we put the 3 times 14. 4 is not 1, right? 5 is not 1. We said 6. 7. Anything else? 8, 9, 10, 11, 12, 13, 14. Anything else? 16, 17, 18, 19, 21. And then what? Anything else? And then 42.
Yes.
All right. Now, 42 itself. Now, the numbers here are, most of them are prime numbers, right? 1, 2, 3, 7. 14 is 7 and 2, and that's prime number. 21, 7, 3, both prime numbers. So when they're all prime numbers, then you really can't simplify it into a perfect square root. All right. I mean, you could write it as square root of 21 times square root of 2, but then those don't factor into a perfect square root. 21, 7, and 3 don't factor into perfect square roots. So when you can't factor it into perfect square roots, you just indicate no solution.
Oh,
Just say no solution, because everything you put in will be a prime number. Say, even if you put the 21, 7 times 3, 7 is prime, 3 is prime. 14, 7 is prime, 2 is prime. Okay. 6, 3 is prime, 2 is prime. So when you have all prime number factors, you just put no solution. Okay, because that can happen. You may not be able to find something with a perfect square root. It could be all prime numbers. And sometimes you ask to put the prime numbers, okay? And you can put them. You have the 6 and the 7. Well, actually, 6 is not prime, but 6 is 3 and 2. So you break it down 3, 2, 7, all prime numbers, okay? You understood what I just said?
Yeah.
Yeah, 3 times 2 times 7, all prime numbers. So when you get all prime numbers, then you can't simplify something any further. Okay. Any questions?
So all you need to write for the answer is no solution.
Yeah. Well, usually it's a multiple choice, and you just indicate only
Oh,
prime numbers.
they
Or
will have the indication there already.
yeah, well, they will probably indicate their. Well, they give you some
Yeah.
incorrect numbers that don't have perfect square roots, and then they say, well, no solution, and you pick the no solution. Got it?
Yeah.
All right, I want you to try. Let's see, I think we got time to try just one more. See if you can factor this one. Now, this one has a coefficient in front of it, and then it has the radical. What does that factor? I want you to factor this. What does 120 factor into? Anybody knows?
Let me see.
What does it factor into, Maureen?
1. You're going to put like from 1 to 120, right?
Yeah, what are factors of 120? Okay, you want to factor, okay, you want to put 1 and the last number 120. Okay, so we know 2 comes next because 2 times 60 is 120. What about 3? 3 times what? 40? What about 4? 4 times 30?
What times 30, yeah.
What about 5?
No.
5 is not a factor.
5 times
24. Yes. 5 times 24,
Oh, yeah, yes.
right?
Sorry.
And of course, 6. 6 times 20. 7. No good, right? 8.
yeah.
No, 9.
9, 10.
10. 10 times 12. Anything else? 12. What else?
Can 15 go?
20 divided by 15. That's 8, right? Okay, 15.
That's all.
Anything else?
Let me try this one.
Anything else? Any other factors? We know 20 is 1, right?
Yes. Mm-hmm.
Okay, so we know 20, so let's just put 20 here. Anything else? $24 is 1.
Yeah.
Anything else? You know 30 is 1, right?
Oh, yes.
30.
Yes, I put 30 with 4.
Okay. Any other ones?
Let's see. Which one? 6. 60
Anything
minutes.
else? 60, okay. Anything
Yeah.
between 40 and 60?
That would be
90.
90?
90 on the street. No.
No, 90 would not be 1. Anything
That is
else
too high.
after the 60? Any others?
Yeah. I don't think so.
Okay,
it's
I reckon too high.
so which one would you choose?
I would choose 60.
What we would choose?
60.
60 doesn't have a perfect square root.
Excuse me?
60, neither 2. So if you chose 60, you'd have 60 times 2. Neither one perfect square root. Pick 2 of these numbers and one has a perfect square root. What would you pick?
Oh, okay.
What would you pick, Maureen?
Okay.
This one in this list has a perfect square root. What is it, Mercedes?
What about 12, Miss Barbara?
12, not a perfect square root.
Ah. Okay.
But there's a number there that has a perfect square root. What is it? I see it.
Okay.
94?
no, sorry.
2 numbers multiply to give 120. One with a perfect
Oh,
square root. 4 and
60.
what?
30.
What?
4 and 60.
4 and what?
30.
4 and 30. Right? 120
Yes.
can
Yeah,
factor
yeah,
into 4 and 30, right?
yeah, yeah.
So you can take the 120. Let's just put this here. Okay. So when you look at your factors, you say, well, what factors into a perfect square root? Okay. So let's just put here. Okay. And this would be equal to 2. And that would be 2 times square root of 4 times square root of 30. So let's put 2 times square root of 4. And let's put square root of 30 following it. All right. Okay, so let's put the 30 here. What is that equal to, Mercedes? What would that
Equal
be equal to?
60.
2 multiplied by
What's the square root of 4?
2.
So that would be 2 times 2 square root of 4. And then we just put square root of 30. And square root of 30 does not factor
That's
into
correct.
any perfect squares, right? So 2 times 2 is 4, and then we put square root of 30, and we get 4 times square root of 30. Okay?
That's 2 times 2 is 4.
2 times 2 is
4
4.
times 30.
One from the 2 here, and the other from the square root of 4. So we've got 4 times the square root of 30.
So 4 times 30 is 120.
4 times square root of 30. Yeah.
Yes.
Questions?
Making a lot of sense and open the brain.
Okay, yeah. So you think factors of radicals just like you think factors of numbers, except they have the radical symbol. All right.
So we could do it all like this and then pick out the radical, right, miss?
Yeah.
It's a
Well,
good brainstorm.
the good way to start is like to list your factors for the number under the radical. In other words, we call it the radicand. So what are your factors of 120? And then once you list them, then you say, well, what 2 can I pick to multiply? And 1 is a perfect square root. And of this list, the only one the perfect square root is 4. Everything else is not.
Yes, yes, ma'am.
Okay,
4 times 30 is 120.
that's right. Because
Yeah.
10, there's no square root of 10 perfect, no square root of 12, no square root of 15, no square root of 20. So you pick out 2 numbers and 1 with a perfect square root. All right.
Thank you,
Yes.
Barbara.
Okay, so we're going to stop here. And I wanted to, scientific notation. Does anybody know what scientific notation is?
Not sure.
Have you heard of it? Well, I want to look at it really, really quick. Okay. And it's a good way of representing large numbers and small numbers. So I want you to know what it is, how you write numbers in it, how you take numbers in scientific notation, write them in decimal form, and then to perform operations. So let me just give you something quickly about it. 12,860. As scientific notation, you shift your decimal point always between numbers less than 10. So in other words, the number in front of the times the 10, and it's always the 10, that's your base. So your decimal point is here, shifted between the 1 and the 2, and the number of places you shifted is the power. And if you shift to the left, it's a positive power. If you shift to the right, it's a negative power. So your decimal point is right here. You shifted it 4 places. And now your decimal point is between the 1 and the 2. So 1.2860 times 10 to the 4th power. Now,
So that
it,
is a positive.
yeah, always positive when you're shifting to the left.
Left.
The negative exponents are for those numbers less than 1, like these decimals. So 0.00327, you shift the decimal point from here to between the 3 and the 2, 3.2 times 10 to the minus 4. If you shift to the right, your decimal point is negative. Any questions on just this part?
No, miss.
Now, okay.
Because it's new, just do it a few times till we get it.
Yeah, well, okay, let's just practice these first two. Okay. Now, 0.025. Now I know I want to shift my decimal point between the 2 and the 5. So this becomes 2.5, right? So my decimal point is here. I moved it between the 2 and the 5. Remember the number before the decimal, the number with the decimal, or it sometimes be a whole number, has to be number less than 10. In other words, you wouldn't shift to the 25. Okay, so since you moved it to the right, the decimal point will be negative. So that's 10. How many places did I move it, Mercedes?
You move it 3 places.
It's right here, and now it's here. How many places is that?
That's 2 places.
2 places. So it's 2 places to the right. So your decimal point would then be a -2, right?
Okay.
So we put -2. Okay. Now let's go to the next number. Maureen, where would I put my decimal point for 645,700? Where would the decimal point between what two numbers?
In front of 2 zeros.
No, where would I put my decimal point? Between what 2 numbers? Decimal point is here. I want to move it between the 6 and the 4. So this would be 6.457. Always times the base 10. How many places did I move it? Move the decimal point, Maureen.
2 places.
From here to here is how many places?
No, it's more than 2
It's
places.
more than 2. How many, Alva?
3.
You say you're gonna move it right to the 6?
1, 2, 3.
I'm right here.
5.
That's
Yeah.
1, 2, 3, 4, 5. 5 places, right?
Yes.
So I put a 5.
I see.
The decimal point is behind that last 0.
Uh,
You don't see it, but that's where it is. All right. And you moved it between the 6 and the 4. So it's here. So 1, 2, 3, 4, 5. And if I move to the left, a decimal point is plus. Got it?
If you move to your left, the decimal point is plus.
That's right. If I move to the right, the decimal point is negative.
Okay.
Okay. So what about this one? What number goes in front of the 10? Where would I move the decimal point, Mercedes? It's right here. Where would I move it? Mercedes, you're on mute.
I beg your pardon. I'm
Yeah,
talking.
okay, where would I move the decimal point? It's right here. Where would I put it? Between what 2 numbers?
Between move to the right.
Correct. And where would it go?
Between 4 and 5.
No, remember the number in front of it got to be less than 10. That would be 44.
Okay.
So
So
where would I move it?
between less than 10. Between 0 and 4.
No, between the 2 4s. So this
Oh.
becomes 4.456 times 10, always base 10. And how many places did I move it, Mercedes?
5 places.
So what would be my power here?
Fifth power.
Plus or minus?
Minus.
Minus. Okay? Because if you're moving from left to right, negative. Right to left, positive. Got it? And the number in front of the times 10 to a power is never greater than 10. It's always less. So you're going to move it to points where it's less than 10. That's why you wouldn't put, let's say you said between the 4 and the 5. That would say 44.56. No, you want 4.456.
Okay. Okay.
Got it?
Okay. The one to the left is less. It's between the 4.
Well, the number in front of the tens to a power is always less than the digit 10.
Okay.
Okay, always less than the digit 10. So that means you don't want to move it 4.5. You want to move it 4.4 because that's less than 10. Just like here, we moved it between the 6 and the 4, not between the 4 and the 5, which would make that 64.5. That's greater than 10. So 6.457 is less than 10. Always less than 10. Got it?
Yeah. Yes, thank you, Mr. Papa.
As you do more of these, it'll become kind of like second nature to you. But I want you to be able to first know what the scientific notation is, know how to write it, know how to go from the number in standard form to a scientific notation, and know how to go from the scientific notation to a number. All right. We'll do some more practice of this, but actually on the homework, I'll give you a couple. All right.
All right.
Any questions on what we've gone over? Make sure you do your surveys. All right. Please do your surveys. They're
Okay.
very important. Okay. So I'll be sending you the homework, and we'll be doing some more radicals, simplifying, and I'll send you a couple of scientific notation problems. Okay.
Uh,
All right. So long, everybody.
Okay, have a good weekend, everybody.
Bye.
Everybody have a good weekend.